Good morning. This is EE 104, lab number 4. So in this lab, the goal of this lab is to design a socket in LT-SPICE or any SPICE simulation and translate that into Python code to give you the same result that you obtain on Python. So we're using matrix method and a cab to be able to analyze a socket in Python from LT-SPICE. That's what I use, from LT-SPICE to Python. So this is the first. This code has different sections, basically 3. So I'm gonna go over all the 3. So the first one that I use here is simple socket, consists only resistors and voltage source, RV socket. So I'm going to analyze it by the operation point, or OP. So after importing a cab, this library ACAB is going to help us to analyze this socket. So in this socket, I am going to run this socket. So basically this is how I translate the socket in here using metric system by the nodes and the value of each socket element in here. So I'm going to run this code. I'm going to run this code. So let me just exit all of this to rerun it. I'm going to rerun this code. So after rerunning this code, so you can see the value of the output of the code that I just simulating. So this is how this code have to be. So unfortunately, the value that I get from LT-SPICE does not really match the one in Python, because I was supposed to design Winston Bridge. Unfortunately, I'm still learning, try to see how will I be able to design it here. So the nodes here, they do not really match with the nodes that I get from the Python, because in Python it was easier for me to input Winston Bridge in there with nodes, but this one, yeah, I designed it differently, so the node did not really match. So that's why the value is not the same as the one simulated in Python. So that's one of the challenges that I face in this in designing this project. Unfortunately, but fortunately for me, the Python was able to give me the real value, because I input the node according to the Winston Bridge socket that I designed on the paper. So the next part of this project is the AC analysis. So the AC analysis is going to give me the AC analysis. Give me a second. Oh, my computer almost about to die. So the AC analysis is going to analyze a Bode plot. So you use a socket, RSC socket. So because of this, we call the AC analysis, because of the AC here of the socket, AC1. So when I run that socket, it gave me a Bode plot. So that same Bode plot analysis is going to input into Python. So you can see how I input the socket in here, element in here, matrix form. So in this code, it's going to plot out for me the Bode plot and the output voltage of that socket that I just showed you in LT-SPICE. So when I run it, this is how this is going to become. Taking a few seconds. So you can see the Bode plot that I get from Python at the end of the day after I run the socket. So this is the Bode plot that I obtained. So now you can see the output voltage, the input and the output voltage, this graph also given to me by Python. So this is what this project is about, to be able to design a socket in LT-SPICE and get the same value in Python. So this is how this socket is about. So I was able to get all those values and point in here. Let me just so you can see the output values after I run the socket, and then these are the nodes input in Python. So that's another part of this lab exercise. So the last one is poles and zeros. So the poles and zeros also is a socket that I designed in Python. So from that socket, you're going to be able to the Python is going to be able to calculate for you the poles and zeros, and then after that also it's going to analyze for you symbolic analysis. So from here you're going to be able to see some graphs, and the 4 graphs. Definitely when you run this code, you're gonna get 4 different graphs, 2 poles, 2 poles, 1 zeros, and then other graphs like the gain among others. So I'm gonna run this code to see what I'm talking about. So this is the code here. We call it P and zeros. So I'm gonna run it. Run. So you can see here the output of this code. So first of all, this is the poles and zeros here. You can see 2 poles and 1 zero. He gave it to me here. So these are the value, the input that I put into the code. So now you can see the graphs. So I'm going to start from the poles and zero. Give me 2 poles. 2 poles, you can see P1 and P0, and the 0 right at the middle. So 2 poles and 0. I'm going to give it to you. And then this is the transfer function, is the analysis, and then this is the transfer function for the poles and zero analysis, and then basically everything combined together give us this graph. So I obtained 4 graphs in this code. So this code is all about that. So luckily for me, all this code that I worked on, they all worked out well. Unfortunately, I could not get the exact graphs or the result that expected, which is the design in LTSPy was not well done, because I'm still learning some tools in LTSPy, and secondly, I just estimate the values. They were not exact value of the socket element that I use here, so that might have been the problem, that I could not get the exact result that is expected of me. Thank you very much.